Hello, this first video is on trigonometry and it's a quick revision of what we've done in the chapter. Very quick before we start into the exam papers, make sure you know the basics. The first thing you need to know is Pythagoras' theorem dealing with right angle triangles, and depending on what way you learnt it in your teacher, you would have a squared is equal to b squared plus c squared. Now often the way I'll write this is I'll write it as h squared is equal to a squared plus b squared. And the letters really don't matter. What does matter though is your hypotenuse, which is h, should always go first. So this one here is your hypotenuse. And then either side then is a or b, it doesn't matter. So we let that one be a, that one equal to b, and h squared is equal to a squared plus b squared. And one of the places you'll see this is in a 3, 4, 5 triangle. So if we have, let's say 5 along the hypotenuse, we have 3 here and we have 4 here. A couple of things you'll always notice. First of all, the hypotenuse is always the longest side. So if you have a 3, 4, 5, clearly the 5 is the longest side, therefore that's going to be the hypotenuse. You'll also find that the hypotenuse is also always opposite the right angle. So in this particular example here with the 3, 4, 5 triangle, what we do is the hypotenuse always goes first. So it's going to be 5 squared equals, and then it's the other two sides added together and squared. So we got 3 squared plus 4 squared, and then you work it out. 5 squared is 25, 3 squared is 9, 4 squared is 16, and you end up with 25 equals 25. So that just shows that these two here, when they're squared and added together, should be equal to the 5 squared. Where this comes up then is if maybe you have some sort of a question. So maybe you have, I don't know, some sort of a building along here, something like that, and you're told that the building is, I don't know, 5 meters tall, and you have, I don't know, a pole or a rope or something like that coming from the building, and then it is 12 meters from the base of the pole to the rope. So this is where you would see Pythagoras' theorem, and I would ask you to find out how many meters is the rope. So we have two sides. We just need to find the last side. It's up to yourself. You can call it or if you want for rope. So we'll say or, and it's r squared. The reason why it's r squared is it is opposite the right angle, and that's equal to 5 squared plus 12 squared. Now again, you did this for junior cert. This shouldn't be anything too difficult. 5 squared is 25. 12 squared is 144, which gives you r squared is equal to 169. Now we're looking for r up here, not r squared. So we need to change r squared. So r then is equal to the square root of 169, and when you tap that into your calculator, r then is equal to 13. Put in your units. And so back up here, the length of this rope is 13 meters. And again, as you can see, that is the longest side. Okay, so that's pretty much Pythagoras' theorem done. Next, what we're going to do is we're going to move on to sine, cos, and tan. Write that down a little bit. And when do we use sine, cos, and tan? We use them when we've got, you know, a right angle triangle. It has to be a right angle triangle. If you're missing a side, we can use sine, cos, tan to find the missing side. Or if you're missing an angle, you can also use sine, cos, or tan. So the first option we've got here is where we have no angle, but we have sides. So let's take a quick example. First of all, you have to know how to label the triangle. So let's say we mark that angle there in this triangle as A. From A, you've got to figure out what each of the sides are called. So of course, as always, opposite the right angle, this is called your hypotenuse, which we're going to put as H. And then the opposite side is the one that's opposite the angle that you're dealing with. Now we're dealing with A up in the top, so this one here is going to be our opposite side. And then finally, the side that's left over is your adjacent side. And again, they'll be shortened to A and O depending on the question. If you have an angle here of B, the hypotenuse is still going to be here because it is opposite the right angle. But in this particular example, B is opposite this side. So this side is now the opposite, where it was the other one in the previous example, and the one that's left over is adjacent. So where your angle is makes a big difference as to the way you label your sides. But let's have a go at a quick example here. Let's say we label this angle here, and this is no angle, So we're going to call this A. We don't know what that angle is. It could be 30 degrees, 45 degrees, we're not too sure. However, we do have a couple of sides. So what we'll do is we'll number this 6 and we'll put this in as 10 and we'll put this in as 8. And what we've got to do is try and figure out what A is. So the first thing you're going to do is, well, you're missing an angle and it's a right angle triangle, therefore we can use sine, cos and tan. So sine is always opposite over hypotenuse. Cos is always adjacent over hypotenuse, and tan is equal to opposite over adjacent. Now, which one of these you'll use depends very much on the question and how much information. We have a lot of information in this question over here, so we'll fill in the sides. So working off angle A, this is the opposite side. This, of course, is your hypotenuse because it's opposite the right angle. And this side on the 6, this is going to be your adjacent side. So because we have all 3 particular ones labeled, we can actually use any one of these and they'll all give us the same result. So for example, let's start. If I was to work with sine, so it's the sine of the angle, the one that you don't know, which is A. So sine is always opposite over hypotenuse. So you put the opposite over the hypotenuse. In this case, it's 8 over 10. And then you work down through your sum. Sine A then is equal to 0.8. Now how do we figure out A? We want A on its own, not sine A. So what we've got to do is bring the sine over the other side of the equals, and it becomes what's called inverse sine. So we got inverse sine of 0.8, and then you go tap that into your calculator. And we have a calculator here, so we go shift inverse sine and then 0.8, and that's going to give us a total value of A then is equal to, what was that? It's rounded up to the nearest one, we'll say 53 degrees. So that works out for that one. But what if you didn't go for sine? What if you went for cos? Well, again, you can do cos of A as well. So in this particular example, it's going to be the adjacent over the hypotenuse. So that's A over H, which is 6 over 10. So again, cos A in this example is 0.6. We want A, not cos A. So we've got to go inverse cos on the right hand side of 0.6. Back down to our calculator, inverse cos of 0.6. So second function cos 0.6, hit equals, and you can see there it is 53 degrees again. So A is equal to 53 degrees. And if you were to do it via tan as well, we'll try and do tan. So tan A. And again, tan A in this example is going to be the opposite over the adjacent. So that the opposite over the adjacent is going to be 8 over 6. So 8 over 6. And again, same thing. How do we find A? A is equal to tan inverse. Now again, I haven't changed the 8 over 6 into a decimal. I suppose I probably should. But if you want, you can just type it in as 8 over 6. And when you work that out on the calculator, again, you're going to get 53 degrees. So, as you can see, it really makes absolutely no difference as to what way you do it. Okay, so that's an example if you have no angle, but you have some sides, and you're missing the angle. So what if we change that around, where we have the angle, but we're missing a couple of sides? So let's take that down here. So in this one, we are going to have the angle. And we're going to be missing a side. So again, let's take an example. So let's say we have something like, let's say 35 degrees here. So there's the angle that we've got. And we have our hypotenuse, which is 8. And often in the question, you'll be given something like this. So this is a triangle A, B, and C. And this question then would say something along the lines of find BC. Now if it asks you to find BC, that's this line here. Again, you can call it X. You need to label it as something. You can label it as X. You can label it as BC if you want. But to figure it out, same thing. You have to label all your sides. So working off your sides, we have a hypotenuse. Okay, that's 8. And the one that we want to find is this side here. Now working off 35 degrees, this is our opposite side. We leave our adjacent, there's nothing there for that, so we just leave it blank. So we're working with opposite and hypotenuse. So to work with opposite and hypotenuse, that's always sine. So the first thing you do is you put down sine, then you put down the angle that you're dealing with, which is 35 degrees. And that equals to the opposite over the hypotenuse, O over h. So you end up with sine 35 degrees, and that's opposite over hypotenuse, which is x over 8. So you have a little equation here that you've got to figure out. Now again, what are we looking for? Constantly go back, we're saying we're looking for x. We need x on its own on one side. So what I'm going to do is I'm going to take the 8 and I'm going to bring it up and I'm going to multiply it in. And depending on your teacher, you might want to bring the 8 up, multiply it in, or multiply both sides of the equation by 8. It's up to yourself. So now what we have is we have 8 times the sine of 35 degrees. It's going to give you x. So x then is equal to 8 times the sine of 35. So in here we can go to the sine of 35 degrees, hit equals, multiply it by 8, and that's going to give you an answer. And again, round it up to 2 decimal places, that's going to give us 4.59. So 4.59. And that's how we find the missing side x. And everything else is done the same way. Depending on what way your triangle is labeled, you may have to use cos if you have the adjacent and the hypotenuse, or you may have to use tan if you've only got the opposite and the adjacent. It just depends. Let's move on. The last bit in the last 15 minutes we'll try and get in is the area of a triangle. So it's again important that you understand how an area of a triangle works. So first of all is, well, the formula for the area of a triangle. The area of a triangle in trigonometry is 1/2 AB sine C. And again, these are all multiplied by each other. It's half multiplied by A, multiplied by B, multiplied by the sine of C, all multiplied. So how do we label each of the sides? Well, in trigonometry, the angles are always written with a capital letter, so capital A, and the side that's opposite it is always written with a small letter A. And the same thing will apply then with capital letter B here, and we got a small b over here. And then we also have a capital C here and a small c here. And that's how you label your triangles. Okay, so let's take an example for the area of a triangle. We'll try and get this one done. So let's say we've got a triangle like that, and we want to fill in some details. So in this triangle here, we'll put in 55 degrees, and we'll also put in 12, and we'll also put in 15. So generally in the area of a triangle, you will have one of the angles, and you'll have a side on either side of it, and that's what you're going to put in. So this A and B that's here, they are references to the sides, because they're small letters, whereas this C is a capital letter, this is the angle. So when we're going to figure this out, we go 1/2 multiplied by the first side, which is 12, multiplied by the next side, which is 15, multiplied by the sine of the angle, which is 55 degrees. And again, all of that can be thrown into the calculator pretty much in one go. So we've got half of 12 by 15 by sine 55. So we've got half, which is 0.5, multiplied by 12, multiplied by 15 equals that. And then we multiply it by the sine of 55. So that's going to give us an answer of 73.72. So 73.72. Now remember, this is area of a triangle, so this will be units squared. And that's all there is really to the area of a triangle. Okay, we'll be back in a few minutes for the sine rule and the cosine rule.